When we look up at the sky on a clear day, it's easy to forget that the bright golden circle above us is not just some light in the sky. It's a star, a real star, just like the ones we see scattered across the night sky. Except this one is close, really close. Close enough to warm our skin, close enough to power every growing thing on Earth, close enough to be both life-giver and destroyer. And yet, so much of it is still a mystery. We've studied it for centuries. We've worshipped it, measured it, tried to predict it. But only recently, thanks to the incredible technology launched into space, have we been able to see the sun not just as a glowing disk, but as a dynamic, violent, and mesmerizing force of nature. In this journey, we're going to dive deep into the sun, not with a spaceship or a probe, but through the language of light. Light we can't see with our eyes. Light that reveals what lies beyond the glow. And once you've seen it the way NASA has, you'll never look at a sunny day the same way again. Let's begin with a strange thought. The light we see from the sun is not from now. It takes about 8 minutes and 20 seconds for sunlight to reach Earth. That means when you squint up at the sun, hopefully with eclipse glasses, you're seeing it as it looked 8 minutes ago. But if we trace that light back, if we follow those photons to their true beginning, we find something mind-blowing. Those same particles of light may have started their journey over 100,000 years ago, deep in the sun's core. Born in nuclear fusion, they spend millennia bouncing, zigzagging, ricocheting through layer after layer of plasma before finally escaping. So when that warm beam of sunshine lands on your face, it's ancient. You're literally bathing in the past. We begin our exploration with the sun's outermost layer, a region you can only see with special tools, or under the rare shadow of a total eclipse. It's called the corona. Despite being the outer layer, the corona is incredibly hot. Over 1,000,000 degrees Kelvin, much hotter than the surface itself. And it's not smooth or static. It writhes, flows, twists, and stretches. Using extreme ultraviolet light, the Solar Dynamics Observatory, SDO, captures the corona in extraordinary detail. You'll see delicate threads and fiery tendrils, shaped by powerful magnetic fields. During a total solar eclipse, when the moon perfectly aligns with the sun and blocks the blinding center, the corona appears like a ghostly halo. It's stunning. But still, what the human eye can see in those few minutes is nothing compared to what NASA's instruments reveal every day. Moving in closer, we discover solar flares, intense, bright flashes of energy that burst from the surface with explosive force. These are not small events. Imagine an explosion powerful enough to equal billions of nuclear bombs. That's a solar flare. They're triggered when tangled magnetic fields snap and release stored energy in a sudden burst. Light, radiation, and particles are blasted out into space in all directions. Sometimes, if Earth is in the path, these flares can disrupt satellites, interfere with communications, and in extreme cases, knock out power grids. But even in their danger, there's something hypnotic about them, like watching a thunderstorm in space. Just next to flares, you might notice something that looks like a scar, a dark patch on the sun's surface. These are coronal holes. While they might look like gaps or empty regions, they're actually cooler, less dense areas where the sun's magnetic field opens up into space. And through these openings, solar wind pours out. Streams of charged particles flowing across the solar system at incredible speeds. When that wind reaches Earth, it collides with our planet's magnetic field and lights up the sky with color. Green, pink, even purple ribbons dancing across polar skies. We call them auroras, but they're really the sun's breath, made visible. Now we come to one of the sun's most dramatic sights, solar prominences. Imagine a glowing arc of plasma, hundreds of thousands of kilometers long, gracefully rising from the surface and looping back down. These loops are so massive, you could fit multiple Earths inside them. They're held together by magnetic fields, and some last for months, swaying and shifting in slow motion. In high-resolution time-lapse footage, you can actually see them move. And it's surreal. like watching a flame dance in zero gravity. But sometimes that gentle motion turns violent. Not all plasma settles back down. In some cases, that built-up tension in the sun's magnetic field snaps, sending an enormous wave of material flying into space. This is known as a coronal mass ejection, or CME. And when it happens, it's like watching a solar tsunami. A massive bubble of plasma, billions of tons of it, erupts and expands, racing outward at speeds of up to 3 million kilometers per hour. If one of these were to hit Earth directly, we'd be in trouble. Satellites could fry. Astronauts would be at risk. Our power systems and technology would be tested like never before. This is why scientists monitor the sun constantly, watching for warning signs, tracking the solar cycle, and preparing for what might come next. Speaking of cycles, did you know the sun has moods? It goes through an 11-year cycle of activity. Sometimes it's relatively quiet. Other times it's wild, producing more flares, more prominences, more sunspots. This rhythm affects everything, from solar weather to space exploration. And it's not just about timing, it's about temperature. Take a look at these two images of the corona, taken at the same time but in different wavelengths of ultraviolet light. One shows a calm outer layer. The other, a storm of magnetic chaos. Same star, same moment. Completely different worlds depending on how you look. Now let's go deeper, into the narrowest but most extreme region of the sun's atmosphere, the transition region. It's only about 100 kilometers thick, but in that short distance, temperatures jump from 8,000 Kelvin to nearly 500,000 Kelvin. It's one of the sharpest temperature gradients found anywhere in the universe. Beneath that lies the chromosphere, a layer that glows with reddish light during eclipses. Here, we discover some of the most elegant, surprising features of all. Spicules. Spicules are thin jets of plasma that shoot upwards at 100 kilometers per second, almost 300 times the speed of sound. They can grow taller than Mount Everest and vanish within minutes. For years, scientists couldn't figure out how these jets even formed. The magnetic fields at that level shouldn't allow it. Until, in 2017, a team found the missing piece of the puzzle: neutral particles. By adding them to their models, suddenly the impossible became possible. Spicules weren't breaking the rules. They were just working with ingredients we didn't realize were there. And now, finally, we reach what most people think of as the sun's surface, the photosphere. It's the part we can see. But here's the thing. It's not a solid surface. The sun has no hard crust. It's all plasma, a strange state of matter, somewhere between a gas and a charged soup of particles. At about 400 kilometers thick, the photosphere is the thinnest layer we can observe in visible light. It's where sunspots form, where granules churn, and where our journey ends. Not because we don't want to go deeper, but because right now we can't. Zoom in on the surface and you'll see something fascinating. Solar granules. They look like cracked lava, or puzzle pieces that keep shifting. Each granule is about 1,000 kilometers wide. Hot plasma rises in the center, cools at the edges, and sinks over and over like a boiling pot that never stops. Each one lives for only 20 minutes, but during that time, the plasma inside can move faster than sound, sending ripples across the surface. It's mesmerizing, beautiful, and completely alien. And that is as far as we can go, for now. We've journeyed from the corona to the chromosphere, watched plasma leap and rain and twist through magnetic fields. We've seen what light can show us, not just the visible, but the ultraviolet, the hidden, the extreme. We've seen a star alive with motion, with rhythm, with energy. The sun is not just a ball of fire. It's not silent. It's not still. It's bursting with life. Solar storms, magnetic chaos, boiling loops of plasma. It's unpredictable. It's essential. And we're just beginning to understand it. Who knows? Maybe the next time we look up at the sky, we'll remember. Every glint of sunlight carries with it a story, thousands of years in the making. And the deeper we look, the more we realize there's still so much left to see.